getting back to our Peggy, our speaker. So, well, Peggy's actually been in town for 25 years, so some of you may know her. And we know her because she's actually one of us. And so many years ago, when she was taking care of her daughter and working and thinking about going to school and wanting to save New Mexico forests, she came there. But obviously not at that time. She couldn't work at 9 in the morning on a Wednesday. So she tailored her own little program. She went in there on her own time. I would see her in there on the weekends. And so that's why I'm saying, if our time frame does not fit you, create your own, because that's how she did it. And now looking, her list of accomplishments in that time frame, since she hasn't been part of us, is quite long, and I'm going to have to read it, because she went back to school to do her goal of saving the forest. So in 2021, she got her associate degree in pre-science at UNM, and I think at this point, were you already doing the math tutoring? Because I think she was already tutoring for math, and at one point she got us involved, I think when you were a forest intern, she got us a chance to go into the Amole forest and dig plants that were going to be ruined by herbicides, I think they said.
Yeah, graveling and maybe
graveling.
Herbicides too.
Yeah,
those
I think they had some things they wanted to get rid of. So we actually got in there. So that was great. In their own natural setting, we were able to dig them up. And to my knowledge, the ones I dug up for myself are still there. So they managed the transplant. So that was something that she's responsible for. So she moved on. By 2023, she got her Bachelor of Science in Forestry from New Mexico Highlands University. And now we're sitting here at 2025, and she has a master's degree. And her presentation tonight is basically her thesis. And I can go on and on. She got her master's in, I guess, natural science, environmental science, and management concentration, which I don't exactly know what that even is. So when she gets up there, I mean, the list of other accomplishments was so long that I thought, oh my gosh, I can't even read this. So I think when she's talking, she will talk a little bit. Are you going to talk a little bit about your goal for the San Cristobal thinning thing, or is that kind of on hold?
A lot of it's been done already. The thinning has happened.
Okay.
So, yeah.
I saw that in the bio when I was going to add it, and then I thought, well, I don't know how much of this is current.
Yeah, I'm hoping to influence future thinning projects.
Okay, yeah, so there you go. So anyway, but I just cannot even express my gratitude and how inspiring this has been to have Peggy, one of us, go from just working to now teaching us after having gotten her master's. So thank you, Peggy. Aww. And we look forward to actually having more like workshops where you could come and do ID or something for us. But we'll send out emails for that. Thank you so much.
Thanks, Catherine. Oh my goodness.
Okay.
Okay, hi everybody. Hi. Thanks everyone so much for coming out tonight. It's so beautiful to see you all here, and I'm excited to share this research with you. So my project was how does concentrated juniper thinning impact Pinyon juniper forests? Our study area was in San Cristobal, New Mexico. It still is there. And that's the ancient homeland of the Taos Pueblo Tiwa, and also an ancient home site of the Kiowa tribe. San Cristobal was also part of a Spanish land grant written for a handful of families in 1815 and 1835. After New Mexico became a part of the U.S., taxes were levied on that land, and families had to sell portions of the grant to pay those taxes. The grant broke into two pieces, and the lower piece was eventually sold to the Forest Service, and the upper piece became the Upper Arroyo Hondo land grant. This is the little town of San Cristobal. You can see it's nestled within all this Pinyon Juniper forest, which is part of the wildland urban interface. We call that the WUI. It's got beautiful fields and mostly acequia irrigated. So Pinyon and juniper are not a timber crop. And because of that reason, a lot of research hasn't been put into Pinyon juniper as much as, say, ponderosa pine or other kind of timber crop species. But I think that Pinyon juniper are more than a timber crop. They've been around in the Southwest for at least 30,000 years, species of Pinyon and juniper, and they've been culturally important since time immemorial as food, fuel, wood for fence posts, tool handles, looms, saddle trees. Pinyon sap was used to waterproof baskets and seal jars, and to add a non-stick finish to stone griddles. And pinyon was used as medicine, for cleansing, and in ceremony. Juniper bark was woven into baskets and textiles, twined to make mats, and used in burials as far back as 5,500 years ago. Pinyon and juniper are ecologically significant in part as wildlife habitat. They support elk, mule deer, and more species of breeding birds than any other terrestrial ecosystem in the continental US. They're important to us as recreation for hiking, biking, hunting, and locally economically significant for fence posts, latillas, fuel wood, pinyon nuts, and Christmas trees. And cosmetics. So this is a map of the western US, and the brightly colored areas are the summer monsoon index, so July through September. And you can see from the red are of course the drier areas in that summertime monsoon, and then down to the darkest blue are the wettest areas. The map shows the range of pinyon and juniper communities, and they extend from the west coast into Texas and from Mexico all the way up to Canada. As many of you guys probably know, pinyon and juniper are called PJ for short, and they represent the most abundant forest type in the US and contain the most hectares of old growth in the US. The map on the left shows 4 kinds of juniper. So down here in the south, we have Juniper debeana. Above that, Juniper monosperma in the red. All this green is Juniper osteosperma. And then here in this blue is Juniper occidentalis. The map on the right shows 3 kinds of pinyon and 1 other kind of juniper. So there's my guy, from the south, we have Pinus symbroides. Above that, Pinus edulis. And then to the west of that, Pinus monophylla. And then traveling down through the Rocky Mountains, all this area is Juniper scopulorum. So pinyon and juniper PJ is a general name for a forest type that contains different soil types, different topography, different elevations, and different species. And it spans the entire western US. And this creates a variability in the ecosystems and makes them difficult to compare, especially in areas of research and land management. Pinyon and juniper forests can be split up into at least 3 forest types, partly based on their fire regime. We have pinyon and juniper savanna, which has a frequent, low-severity fire regime, less than 10% tree canopy cover, and deep productive soil. And we have pinyon juniper wooded shrubland with a variable to infrequent mixed severity fire regime. And in that forest type, shrubs, herbs, and trees tend to be ecologically co-dominant, and we find very few mature trees there. And we also have pinyon and juniper woodland, also called persistent woodland, and that has an infrequent high-severity fire regime. It has 25 to 70% canopy cover. All tree age classes are represented, and we also can find trees greater than 300 years old. The understory in that area is substantial or little to none, and soil tends to be shallow with a coarse, cobbly texture. And dense woodlands are not abnormal. So our study area is a bit of persistent woodland and a bit of wooded shrubland. And persistent woodland is really interesting because of its fire regime, low frequency and high severity. It has that fire regime because it has a heterogeneous fuel load, meaning that the ground fuel is not evenly dispersed. It's not connected to carry a fire. So in order for PJ woodlands to burn, we need high severity fire weather. We need low humidity, high winds, high heat, and the fire needs to climb into the treetops and spread by the wind from tree to tree, and in that way, it kills patches of the forest. And that's a natural disturbance regime for this forest type. And historic range of variability is a really beautiful and useful concept, but it did not really exist before the 1990s. It encompasses all the natural states, phases, patterns, and processes that the woodland has historically existed in, including after a severe disturbance. So to understand what might happen today with our warming, drying climate and erratic precipitation, it's helpful to understand historic conditions and how the forest responded to disturbance. We'll get into a little history of pinyon and juniper and management goals in pinyon and juniper woodlands and pinyon and juniper shrublands and savannas. They weren't called this back then. It was all just pinyon juniper. But management goals have changed throughout the years. In the late 1800s, PJ were heavily deforested in the Southwest, especially in Nevada. The wood was used to make charcoal to heat the mine smelters, as well as for fuel wood, fence posts, and mine props. So we can see this picture here on the upper left is a wagon team of mules pulling a wagon full of bags of charcoal. And you can see that the hillside behind them is denuded of trees. And this picture on the right is a beehive-shaped oven used for making juniper charcoal, as well as mountain mahogany charcoal. But that, I don't know, I think that's pretty cool. And maybe we could think about incorporating something like that to think about biochar production today. Just a side note there. Early management in PJ forests, where foresters thought that the best use of pinyon juniper was as rangeland. And so after World War II ended, we had an excess of machinery and fuel, and we put that to use clearing the trees from PJ forests. So I want to share with you the language that early foresters used to put this into perspective. They called PJ a king-sized weed patch. Weeds in need of eradication, tear out the pinyon juniper, burn it, and seed it to grass to create livestock forage. And you can see that is a quote. David Tidwell was talking about this at a pinyon juniper conference, and he's the assistant to the director of the BLM. An efficient way to clear the trees was a technique called chaining. And I'll show you a little video of that.
2 million hectares of forest were cleared for agriculture. One of the most effective way of clearing thick forestry land is chain brushing, with the chain attached to a bulldozer. The chain is then dragged across the ground, tearing up and uprooting trees, shrubs, and other vegetation on its path. This method is often used in areas with dense vegetation, such as forests or overgrown fields.
Yeah, it's still used today. And yeah, it's in one of the movies about Taos, Milagro Beanfield War. You can see them chaining trees in that movie. All right, this is a map showing fire hazard class across the US, and it's in relation to the wildland-urban interface. Here we are, right here in this orange and red area. The dark red is a high fire hazard if not treated, and the orange is just in general high fire hazard. So this brings us to the new current management goal in pinyon juniper, which is fire mitigation in the wildland-urban interface. And the wildland-urban interface is growing. From 1970 to 2000, it expanded by 52%. Another 10% of growth is expected by 2030. Most of the WUI is on private property, and 87% of large wildfires were fought primarily to protect private property. Much of the fire mitigation treatment that is used in the forest today are based on frequent fire systems, like ponderosa pine, and those treatments used in ponderosa pine are also called restoration because they are restoring ponderosa pine to their historic range of variability. But Pinyon juniper doesn't have a frequent fire interval, and so we're using that same fire mitigation technique in Pinyon juniper, and so it's not necessarily restoration when we're doing it there. It's just a sacrifice for fire mitigation. All right, this is my husband, Johnny, over here. He did a lot of field work with me last summer and the summer before that. And this is the treated area. There's a fence line here, so this area behind that is private land, untreated. And this idea for this project came to me over the period of a couple years, but one day, Johnny came home, and he's a sawyer for a thinning crew in San Cristobal, and he said, "We're cutting all the juniper trees." And I was like, "What? Why are you doing that? They're the last on the list of trees to keep. So when you have a choice to make as a sawyer between juniper or pinyon, you're going to cut the juniper to save the pinyon." So other land management agencies actually take out every single juniper tree when they do fire mitigation treatments. When I was at a class about a year and a half later at Highlands, we had a guest speaker, and he came to tell us about pinyon and juniper. And he mentioned that this was happening, that juniper were being cut out of the landscape. And he was really concerned about it. And so this kind of brought me back to that day with Johnny in the kitchen, thinking about they're doing that right here in our backyard. So I thought, I'm gonna research this. And luckily, the foresters at Highlands thought that was a good idea too. And so here we are. And in this process, I've found that concentrated juniper removal does not just happen here in Taos, it's actually kind of widespread through the Southwest. It happens also in Arizona. The practice seems to be based on a little science and a lot of bias. So my question is, how does concentrated juniper thinning impact the health, growth, and regeneration of the remaining trees? And we'll get into my methods a little bit. This is Khan Namba. He's from San Cristobal, and he's a student at Highlands in Forestry, and he helped me collect a lot of my forest health data. So here we are looking at a juniper monosperma tree, and you can see these little holes, horizontal line of holes in the side of the tree. And those are from the sapsucker bird. They're related to the woodpecker, but they poke holes in the tree and drink the sap. And they find favorite trees they like to keep coming back to. So this monosperma is one of their favorite trees. And this is my daughter here, this in the middle. She helped me on a lot of field days as well. And her name is, any guesses? Her name's Juniper. So San Cristobal made it on the radar of foresters as a wildland-urban interface because of the Llama Hondo fire in 1996. What started as a trash can burn quickly ran 6 miles north from San Cristobal to Llama. It burned more than 10,000 acres and around 24 homes. And the wildland around Llama was mostly ponderosa pine forest, as I understand it, and now it's all gamble oak, which it's a pioneer species and it's just doing its job, but it's a little disconcerting when you've known a forest type your whole life, and then it changes all in a day and you're left with something else. So for humans, our time scale is much shorter than the natural world. But it's important to note that this fire did not impact my study area. My study area is south of San Cristobal, and this fire burned north. All right, here's my study area. You can see it's in Taos County, and it's in the foothills of the Sangre de Cristos. The elevations range from 7,300 to 7,600 feet. The treatment was conducted in 2019, and it was a thin from below with pile burns. Thin from below meaning they cut out all the smaller diameter trees in the thinning. And they used pile burns to handle the slash, to get rid of the slash. The tree species in my study area are Pinus edulis, Juniper monosperma, and Juniper scopulorum. So that's 2-needle pinyon or Colorado pinyon, 1-seed juniper, and Rocky Mountain juniper. So this dark blue area we see are where all the treated plots are. And that is Forest Service land, as is this light green color over here. That's all control plots. And originally I had 20 treated plots and 20 control plots. But later on in the study, I had to add new plots, and luckily I found Rancho Milagro, and they would kindly let me install some study plots on the land. So that we'll talk more about that. Oh, I wanted to show you one more thing. See this little kind of donkey leg looking thing right here? You'll see that in the maps to kind of orient yourself with where you're at when you look at the different maps. All right, this is a soil map from the NRCS Web Soil Survey. And here's our donkey leg. And then here's my treated area. You can see the fence line here of the untreated area. So this side of the east side of my study area has a different soil type than the west side. The east side is a Rejas stony loam. It's well drained with a maximum calcium carbonate of 7%, and the horizon profile is stony loam for the first 2 inches, followed by very cobbly loam down to 14 inches, and under that is solid bedrock. This west side soil type is the Orthents Haplocalcids Association. It has a maximum calcium carbonate of 10% with gravelly loam down to the first 60 inches. And these soil types point our study area into the realm of persistent woodland because of their calcareous horizons, their coarse gravel, and their cobble textures. We have a couple graphs here from PRISM climate data. On the left, here we have the monthly average temperatures and average total precipitation averaged over the last 30 years from 1991 to 2020. The temperature is here on the y-axis in degrees Celsius, and then precipitation is on the second y-axis in centimeters. The graph on the right is the same kind of thing, but it's just averaged over the last 6 years. So the year of treatment, 2019, and then the 5 years after that to 2024, all of last year. And we can see one of the main differences here is the drop in precipitation in April. And 30-year normal average annual precipitation was 35 centimeters, while the average annual precipitation these past 6 years was 30 centimeters. Oh, I wasn't ready for that. This kind of bimodal precipitation pattern that we see points to our study area as maybe being wooded shrubland. So it can be hard to decide what kind of Pinyon juniper you're working in. Okay, I'm going to take a little drink of water. My research was conducted 5 years post-treatment, so I had to find areas that still had juniper trees. After the treatment, we drove around with J.R. Logan and looked for areas. So this was one of the few areas that we found in San Cristobal that still had juniper trees, visible, and decided to put our study area here for that reason. So we started out by, in the treated area from 2019, I placed 50 random points that I generated in ArcGIS Pro. And then we surveyed those points in 2023, in the fall of 2023. We surveyed all those, and we looked at juniper trees, pinyon trees, and then the stumps of juniper and pinyon trees to kind of calculate what was the percent composition of juniper to pinyon before and after the treatment. So the pre-treatment composition was trees and stumps, and we divided that by the total trees plus total stumps, whereas post-treatment was just juniper trees divided by total trees. So this gave us 2 kinds of treatments. We have composition altered, which we're going to call CA, and that means the ratio of pinyon to juniper was altered by more than 15% from the treatment. Then we have composition unaltered, meaning the ratio of pinyon to juniper was altered by less than 15%, less than or equal to post-treatment. And you can see some numbers crossed out here. My original study had 10, n equals 10 of each of those treatments and n equals 20 of the control. The control plots were originally over here, and I just threw in a bunch of random plots in ArcPro, and then I was able to pull out their slope, aspect, and elevation, and I paired those with the treated plots, and then randomly selected one for each treated plot. The plots are circular, 0.04 hectares, with nested 0.004 hectare subplots, with a minimum of 30 meters between plot centers. Here's a little graphic of my methods. So we called, the first thing we did was measure all the stand characteristics of the trees. And trees were everything over 1.4 meters high. We recorded their species, their height in meters, and their ground line diameter in centimeters. All the live trees also got a unique tag number, so we could revisit them. Then we also recorded canopy cover with a densitometer using methods from the New Mexico Forest and Watershed Restoration Institute. We looked at the regeneration within the 1/100th acre nested plot, the 0.004 hectare nested plots. And we got species, their height in centimeters, their ground line diameter in millimeters, and their density. Every regenerating tree got a little tag too with a unique number. And then we came back again in the fall and we got all those measurements again along with their mortality. We also recorded understory vegetation percent aerial cover using ocular estimation with methods from NMFWRI. So that was for grasses, forbs, shrubs, cactus, but we also speciated the grasses when possible and recorded the invasive plants to species. We found mullein, cheatgrass, and Russian thistle. We also gathered a small amount of soil from each plot center to calculate bulk density of the soil. So in May and June of last year, we visited every single tree and looked for signs of Pinyon ips beetle, which would be their exit holes and a little bit of frass around the exit holes. And we also calculated the dwarf mistletoe rating with the Hawksworth dwarf mistletoe rating system. And just a quick overview of that, you split the tree crown into 3 sections, and each section can have a rating of 0 to 2. So a tree can have a total rating of 6. And when we were almost finished measuring all of the stand characteristics and tagging all those trees, and yeah, it took a long time, but we were almost done with that. And then most of my plots were cut down. So all of these plots here, you guys have probably seen this thinning area in San Cristobal. They just cut down 1,000 acres, boom. And we went up one day to finish measuring with one of my professors, and we heard like 15 chainsaws buzzing. It was pretty crazy. I cried. It was, and luckily, thank you Rancho Milagro, they saved the day, and I was able to put some plots in there. But because of the timing of everything, I had to cut the number of plots I was studying in half to make this happen. So that's that. This is my daughter, Juniper. She's making tree tags for us. We made all our own tree tags. Yep, that was part of the thing. That took a long time. It was fun. And we'll get into, oh, wow. I haven't even been looking at my cards. Let me catch up to myself here. All right, this is our first graph. We're going to have preliminary composition results. So we started with 50 preliminary survey plots. 7 of those had to be excluded because of steepness and also because of a little danger in some other plots. So this is the juniper composition difference, pre-minus post-treatment. And you can see composition altered is all these dots here, and composition unaltered are the triangles. So 70% of the initial plots had their composition altered after the treatment. Quickly with analysis, my basal area is meters squared per hectare. It's based on the ground line diameter instead of the forester's DBH, which is diameter at breast height, usually 4.5 feet. Pinyon and juniper branch so low to the ground that you just measure them at the ground. And this is my calculation for basal area. Dwarf mistletoe rating was the average of dwarf mistletoe rating across the plot. So even trees that don't have it, you just average everything from 0 to 6. And DMI is the dwarf mistletoe intensity, and that's the average of just the trees infected with dwarf mistletoe. I used ANOVAs and RStudio, transformed the data as needed to keep post-hoc testing on significant alpha results, p-values of less than 0.05. So I have two tables for you. One is Pinyon, and the next one is Juniper. So we can see these A, B, that's significant differences between these categories. So we have our treatments here, control, composition altered, and composition unaltered. Then across the top here we have live trees per hectare, live quadratic mean diameter, live basal area, and snag TPH. Snags are just standing dead trees. And as to be expected, we see a reduction in live trees per hectare after the treatment, and a reduction in basal area after the treatment. And it's kind of interesting that we have significantly different for every treatment live quadratic mean diameter. And that's the diameter of the average tree that you're going to run into in that area is the quadratic mean diameter. And in general, we saw a density reduction of greater than or equal to 90% between just the treated areas and the controls. So here's for juniper. We can see the same kind of pattern here, reduction in trees per hectare and live basal area, but quadratic mean diameter is not different between all the treatments. Here's the graph of the tree diameter distribution, and remember that trees are taller than 1.4 meters. My y-axis is trees per hectare, and these graphs have a little bit of a different y-axis each. The first one is my control, so it goes from 0 up to 800. My composition altered goes from 0 to about 100 at the top, and then composition unaltered goes up to 120. Whoop. So we can see some patterns. There's nothing significantly different, but we can see that this cohort, Pinyon is blue and Juniper is orange. The cohort here of the lowest diameter trees was the largest in the control. And that's been reduced after the treatment, which is also to be expected in a thin from below treatment. And we can also see here, we have the proportion of Pinyon to Juniper in the control of the 20 to 30 diameter range is relatively even, but when we move over here to the composition altered, Juniper is no longer present in that range. For regeneration, these are box plots with a scatter plot laid over to show density of the measurements. This is the diameter of the regeneration. It goes from 0 to 60, and it's in millimeters. And this line here is the median of the data. So 50% of the data is in this area here. 50% of the controls right in here. So I just want to explain box plots a little bit. And these two graphs are separated by species. So we have Pinyon on the left and Juniper on the right. Pinyon regeneration density in trees per hectare was significantly different between control and composition unaltered, the yellow. But regeneration density was not significantly different between the two treatments, CA and CU. In general, the treated areas had 75% fewer regeneration than the control. The greatest amount of regeneration we found was in the 0 to 3 millimeter size class. You can see that density down here in control. And that size class is mostly missing from the treatments. The mortality that we found, 88% of it was in that 0 to 3% size class. the composition altered and composition unaltered did not have significantly different mortality rates. Juniper regeneration was 0 in composition altered. We didn't find any in either of the 5 plots. And in composition unaltered, juniper regeneration was 67% less than compared to the control, but that was not statistically significant. Here's our understory results. So we have aerial cover percent, so each of these graphs go from 0 to 100. And then we have control graph, then composition altered and composition unaltered, and the colors are these plant types. We have cactus, forbs, invasives, native grass, shrubs, trees, and yucca. So nothing was significantly different between these variables and the treatments, but we can see some interesting patterns. We can see that trees, which are yellow, and grasses, which are green, switch dominance after the treatment. We can also see that shrubs are relatively unchanged with the treatment. And we can see that invasive species are more present in the treated areas than in the untreated areas. Of those invasive species that we found, cheatgrass was the most numerous. Yeah, I just want to mention that the treated areas had 3 times the amount of invasives as the untreated areas. All right. Grass species were also very numerous in this study. We found 8 types of native grass. Does anyone want me to name all those types? We can talk about it later if you want to hear them. And we also found 2 non-native types of grass. So this graph on the left is a box plot. The dotted line is the mean of the data. The y-axis is native grass aerial cover percent. And then we have the treatments at the bottom, control, CA, and CU. And we can see that we have significantly more grass in the treated areas versus the untreated areas. And the graph on the right, I'm going to highlight bottlebrush squirreltail grass because that was the most abundant grass we found in every single plot out there. So that was also significantly different between the control untreated area and the treated areas. All right, plant basal ground cover is the actual area of the plant that's going into the ground versus the percent aerial cover is kind of where it covers the ground, the drip line of the leaves. So this is just where it's going into the ground. And plant basal ground cover percent is on our y-axis. The treatments, again, are on the x-axis. And we can see a significant difference in plant basal cover between the control and the treated areas. Litter, bare soil, rock, and gravel were not significantly different between the treatments, though control tended to have a greater amount of bare soil. And we'll get into soil bulk density. This is positively correlated with soil compaction. It's a measure of soil compaction. It affects water infiltration, rooting depth, water holding capacity, porosity, nutrient availability, and the activity of soil microorganisms. Bulk density was significantly lower in the control area compared to the composition altered area. All right, this is one of the few bark beetles that we found out there. It's a Ips confusus little beetle. They were very rare in the study. We found them only on 1 tree out of all the plots. So it was a bad year for bark beetles, a good year for the forest. But we did find a lot of dwarf mistletoe. And none of these none of the results are significantly different. You can see they all have A's. But we can see, again, some interesting patterns that control for altered had a greater presence. I think this number here on the right is wrong. I'm sorry about that, but I just noticed that. I was messing with this table before I got here tonight. But this is the presence in percent, so the percent of trees affected. Control had the lowest presence of mistletoe of all the areas. Same thing with dwarf mistletoe rating. Control also had the lowest DMR rating. And then the DMI, the intensity, was equal throughout all the treatments. All right, we'll get into the discussion. And this is my friend Jara. She helped a lot with doing all the grass identification and all the plant aerial cover kind of stuff. She's also a forestry student at Highlands. So we saw a density reduction of greater than 90%, and that is not really normal in natural disturbance, save severe wildfire. In natural disturbance, in Pinyon and Juniper is often insect and drought related. And in the past, we've seen a reduction from that. We've seen in the 2002-2003 drought and Ips beetle outbreak that maybe a lot of people remember. We lost a lot of pinyon trees during that time. Some areas lost more than 90% of their pinyon, but juniper only saw like a 10% mortality during that time. And this type of density reduction can actually decrease the local groundwater and leave the woodlands more vulnerable to drought. It can also reduce pinyon regeneration. In that 2002-2003 drought in the Southwest, bark beetle outbreak, there was a study done and they found that juniper trees actually facilitate pinyon regeneration. It doesn't matter, like the number of pinyon trees that were left that survived the drought didn't matter, but the number of juniper trees on the landscape mattered for pinyon regeneration. And this type of density reduction can also negatively impact birds. Pinyon jays are a species of emerging concern in New Mexico, and San Cristobal's within their habitat range. Pinyon jays require between 400 to 1,200 trees per hectare for nesting. And this is a tree density that also benefits other bird species, like the juniper titmouse, the gray flycatcher, Bewick's wren, and the black-throated gray warbler. All have habitat in San Cristobal. All right. So understory in general has an inverse relationship with overstory. And that inverse relationship meaning that as you cut the overstory, the understory gets more light, it gets more growing room, and it fills in. And that's one of the reasons why thinning in a water-limited area does not increase your groundwater. Because as that understory fills in, it starts to use up that excess water. And after 5 years, you can actually see the groundwater levels drop to below pre-treatment levels. We saw a lot of bottlebrush squirreltail, and that is a great thing because it's actually a competitor to cheatgrass. And it shares properties with cheatgrass, like being an early cereal species and also being highly adapted to fire. So that's a good thing that we found that. And I think that that's going to help this area recover because we have cheatgrass present now in the treated areas, but there's so much squirreltail that's going to help. So in a few years, maybe we'll see less cheatgrass there. And we saw similar shrub cover between the treatments, partly because of the pile burning that they used instead of broadcast burning. And pile burning can be more selective with where you put your piles than broadcast. Our soil bulk density was likely a result partly of the soil types. 5 of the 10 control plots were over here in the Orthanth Haplocalcids Association. And remember that the control plots had the lowest bulk density. The rest of the plots were in the Orejas stony loam, which had like gravelly loam to 14 inches and then bedrock. So that's part of that reason. Another reason why the control areas may have generally lower bulk density is they have greater organic matter from the conifer needles dropping. Pinyon and juniper both drop enough needles to cause morphological changes in the soil beneath the canopies. The organic additions to the soil reduce the amount of clay in the soil, and the most nutrients you find in a pinyon juniper forest are going to be under those trees in the needles. Slash pile burning and broadcast burning release pulses of these nutrients, which are often taken up by non-native plants. And we saw that in this study. Most of the invasives we found were in and around the pile burns. Burnt slash piles can increase soil ammonium by 50 times in the first year, and these levels can return to normal after 5 years. So here's some pictures of our forest health surveys. These guys on the left are the gregarious sawfly larvae, and they are super cool. If you ever see them when you're out hiking, you can kind of run your hand over them and they all sort of move together at the same time. They're fun to play with. And then we have some bark beetle gallery right here in the one pinyon tree where we found bark beetles. We have bark beetle gallery and also some wood boring beetle gallery. This here you may have seen in pinyon trees. We found them on almost this kind of, we thought it was red band fungus, and we found it on almost every single pinyon tree in the treated and control areas. And I've been working with the regional pathologist for the Forest Service down in Albuquerque and sending him samples. And so we think that it's not red band, which is great, but it's likely some kind of needle miner insect. And then there's a secondary fungus that moves in after the needle miner is done. Down here we see a little dwarf mistletoe. Pinyon ips, bark beetles, are a native insect, and they have the ability to create a major disturbance in the forest. Tree density can be positively correlated to a forest stand's susceptibility to bark beetles and mistletoe, but tree diversity can reduce a stand's susceptibility to insect herbivory. Monoculture stands are more prone to bark beetle outbreak than those in a mixed composition. This is because the volatile chemicals from the host tree mix with the volatile chemicals from non-host trees, and they kind of muddy up the air, and they make it harder to find those host trees. Pinyon pine dwarf mistletoe are a Southwest native parasitic plant. They're an obligate parasite and require a live host. Dwarf mistletoe can shoot pressurized seeds an average distance of 10 meters and up to 16 meters. Dwarf mistletoe grows within the xylem of the host tree and takes all its water and nutrients from the host. The host tree is weakened and becomes less resistant to drought and bark beetle pressure. So the 2019 forest prescription considered mistletoe, and they prioritized cutting trees that have mistletoe to keep the DMR at less than 1%. But we found that in the untreated areas, DMR is less than 1%, while in the treated areas, DMR averages 1.4%. Juniper presence can mitigate the amount of dwarf mistletoe in a stand and its rate of spread. Juniper trees are not a host plant for dwarf mistletoe, and they act as a shield to screen pinyon trees from the projectile seeds. But unfortunately, in the treated areas, the density of trees is so low that there's really no trees between the infected trees to screen them. So the seeds can shoot and reach other trees even at 30 feet apart. All right, we'll go through my key findings. That the practice of concentrated juniper thinning did not influence the survival and abundance of pinyon regeneration. In general, thinning negatively impacts regeneration abundance. Regeneration will grow to become our future forest and will eventually replace trees lost by drought, insects, and other disturbance. We saw minimal juniper regeneration in this study, and that raises concerns for future pinyon regeneration because they act as a nurse object and facilitate the growth and survival of pinyon trees. And minimal juniper regeneration also raises concerns for juniper because they are an important component of the ecosystem. For understory vegetation, we found that concentrated juniper removal did not positively influence understory vegetation. Thinning treatments in general increase non-native plant species. And in general, the concentrated juniper thinning did not improve forest health through dwarf mistletoe reduction. Thinned areas showed a trend for increased dwarf mistletoe presence and rating. Juniper trees in the composition can help screen pinyon trees from dwarf mistletoe and projectile seeds. Juniper trees in the composition also serve to mitigate pinyon ips and bark beetle attack. All right, last slide. This is our take home. So what I want y'all to remember tonight is that Pinyon juniper vegetation are part of the wildland-urban interface, and they are being affected by wildfire mitigation that has few ecological considerations. There's a long-standing bias against pinyon and juniper, and it now appears just to target juniper for its removal. There's no scientific reason for the bias. Junipers are called weed trees. It's said they take all the water from pinyon, and if this was true, we would have seen significant differences between composition altered and unaltered in areas of regeneration, forest health, and understory reinitiation in these 5 years post-treatment. Juniper are valuable trees. In the composition, they add resiliency to the forest by handling drought and insects differently than pinyon. Juniper offer different wildlife benefits than pinyon, and juniper promote the regeneration of pinyon. Removing juniper during the treatments does not positively impact the forest, but it actually may invite ecological damage. And we should prioritize local research to understand the historic range of variability of these areas before we treat them, because pinyon juniper, like we talked about earlier, they're so different everywhere you find them. We should also prioritize long-term research, greater than 10 years, to understand the effects of these fire mitigation treatments in general. Future work for me will hopefully involve collecting increment cores to understand the treatment's effect on basal area increment growth, and also we'll gather some pinyon needles to analyze their carbon isotope discrimination and the drought stress between the treatments. So part of this project was just documenting what is happening to the structure and composition of pinyon and juniper in the Southwest. And this is the first study in Region 3, the Southwest, to document and analyze the concentrated juniper removal from PJ systems. Yeah, and we have 15 minutes for questions. Yes. Your question was, this fire mitigation treatment in pinyon juniper, it's just for fire mitigation. It's not ecologically oriented or driven. And no, that's right. It's just fire mitigation.
So, I mean, would it be possible for you to study places, I don't know when they started this mass juniper promotion of, fire, but to study some of the earliest areas that was done. Have you?
That's a great idea. There's so much research that needs to happen within pinyon juniper. There's another study similar to this one happening in northern Arizona right now, because they're also concerned about this. But there's it's hard to come up against that bias sometimes and talk to it. So more research is needed, and I love that idea. That's a beautiful idea. Thank you. Yeah, thanks for that reminder. Hi there. The idea was to look at areas that were thinned like the longest time ago and see how they're recovering from that thinned treatment and see how they're developing now. And I like that idea a lot. Thank you.
Well, I noticed after the drought you talked about that, a lot of pinyons died everywhere, but they came back, so quickly. Anytime there was any shade available, a dead tree. So is that the thing that junipers provide?
Yeah.
When pinyons die from drought?
Yeah, when pinyons die from drought, junipers act as a nurse object. So they can shade it, they can also share water with it. There's something called hydraulic redistribution, where the roots have all this water during the day they've pulled up, but then at night they're not photosynthesizing as much and they let that water go. Also, something cool beneath the juniper trees is that the needles are kind of waxy that have fallen down, and they create this barrier. So water can infiltrate and trickle in, but it doesn't come back out. Yeah, it doesn't evapotranspirate back out. So you'll often see big juniper trees with lots of little baby pinyons underneath them.
Where do sagebrush fit in?
We did have sagebrush in this study area. And sagebrush also act as nurse objects for pinyon trees.
Yeah, you see lots of baby young pinyons popping up in the sagebrush fields all around.
Mm-hmm.
Yeah.
Yep, and sagebrush are also one of those plants that's misunderstood, and they have allelopathic abilities where they may like hurt other plants that grow near them, but it doesn't seem to affect pinyon trees. And I've seen a lot of grasses and things come under sagebrush too. So, yes, sir.
I've been running a 30-year experiment on my 1 acre above Pinyon. About half of it, I've just it's a mixed PJ on a west-facing, very dry slope. About half of it I've done nothing. On the other half of it, I've been slowly taking out some trees, not many of the big trees, a number of little trees, some pinyons, some juniper, partly for fire mitigation, actually entirely. I've been leaving trees close enough so that the ground is always shaded. There's a couple areas where trees died off on their own, but the areas I've treated, I make sure that there's regular tree shade on the ground. I've noticed that pinyon regeneration is very good, and juniper regeneration is absent, as far as I can tell, in my neighborhood. Also, the junipers are getting hit worse every year by mistletoe. For what my observations are worth. The reason I bring it up is because other homeowners who live in the PJ are faced with the same problem. Should they leave all the trees alone? Should they take 10% of them out, 5% of them out? And I know there's no absolute answer for that, but I just thought I would bring it up as something that interests me is a great deal, because I want to preserve the forest or help the forest as I can, and make it slightly less likely that my house will burn down in case of a fire.
Yeah, I can appreciate that.
And I don't know, those may be contradictory goals. I don't know if they could be complementary goals or not.
Yeah, so one way to look at the forest is to look at its natural disturbance patterns, and that's what we did with ponderosa pine, right? Well, originally foresters said, no fire, no fire, and look where that's got us. They've removed ponderosa pine from its historic range of variability, and now we're playing catch-up, trying to get it back into place. And luckily that catch-up just involves cutting trees. But when you've cut all the trees down, and then you try to play catch-up to get it back into a historic range of variability, that doesn't work as well. But when an aspect of Pinyon juniper that really needs to be researched are areas that are completely untreated, and to see how these opening patches are dispersed within that. And I saw some really interesting stuff in Rancho Milagro because they don't have tree harvesting, and you could see the ancient remnants of that 2002-2003 bark beetle outbreak, and there was openings and big dead trees in the center, but not a lot going on around them. And it looked pretty cool. So kind of mimicking that disturbance, that natural disturbance on your land, like potentially, taking out patches of trees, clumps of trees. And juniper, it's interesting that you're not seeing juniper regeneration, because pinyon trees are the climax tree. In times of plenty, pinyon will eventually take over and juniper become less and less important in the composition. But after like a big disturbance, a large disturbance, junipers are those first trees that come in there, and they kind of pave the way for pinyon to have a place. And I'd love to talk to you more and come check your land out.
You're welcome to. I haven't recorded things scientifically, but I have been watching it over pretty closely over these 3 decades and seeing what it would do. I'd be glad to show it to you. It's 5 minutes from now.
Oh, cool. Great. Thank you. Did I see a hand in the back?
I know your research is more about the PJ areas, but do you have any educated opinions on the role of
That's interesting. So there's, so if ponderosa pine were to burn naturally every 5 to 25 years, like it wants to, it would probably decrease that amount of ecotone that we see with juniper mixing with ponderosa pine. But what an interesting study, I think it was Huffman, did some studies in New Mexico and Arizona, and they found that fires that happen in the ponderosa pine do not tend to spread it down into the PJ. So there would probably be less mixing in that ecotone that we see, but it wouldn't necessarily give us less pinyon and juniper. But yeah, with they're not fire adopted, pinyon and juniper, like ponderosa is.
So juniper would be less present in the ponderosa pine forest if there was more healthy fire?
I imagine that that's the case. That juniper would be less present in ponderosa pine forests if there were fire as frequently as it likes. Yes, sir.
Did you find any Depiana?
No,
None.
no, we just have monosperma and scopulorum.
Yeah.
Yeah, I don't think you're going to see Depiana until you get more west. Or is that alligator juniper? Depiana and south too. Then there's a lot of alligator. Yes.
You came up with some clear results. What's next? Does it go to the Forest Service, the BLM for their future decision making?
I have to finish editing my thesis, get that turned in, and then we're going to work on a manuscript to publish. So once it's published, then it can be more widely available for people to hand out to the foresters that they know. Yeah. Right? Yeah. So, yeah, hopefully it makes a difference. But sometimes, it's a drop in the bucket. But it felt important to me to do this research.
I was looking, they did a thinning project where I am, and I actually, they won't really talk to me because I got very upset. They burned so much. I mean, they burned all these cedar coats that I thought I was going to be able to get. They burned everything. They said, oh, we have to do it to fulfill our contract. And I said, they grow really slowly. I mean, that's my impression. I looked at the trees, and they're so small. It was just so upsetting. So I'm afraid to even get right down and yell at them and they're burning all these, 6, 8 foot, 10 foot. I mean, I was just so upset. And I don't know what to do about it. They just act like we're doing you a favor.
Where was this at?
Like it's on private property, not that far from private property.
Oh, yeah. Yeah, when you're a big institution, you have to meet your goals. You have to say, I treated this many acres of forest. So it's not necessarily about ecology and not necessarily about saving that wood and being the most responsible with the resources that we're extracting from the forest. But a lot of times I feel like for those agencies, they have to meet their target. They got a bunch of money for the Hermit's Peak Calf Canyon fire. We're a priority landscape, and it was all about cutting trees down and getting rid of the slash, which happened in my control area. They cut 1,000 acres, and they didn't even cut the limbs off the boles of the tree. They just left them lying down, and it was really, really strange. And they're lucky that we were in a low bark beetle year, because that would have been a great way for bark beetles to, yeah.
Do they ever have thinning where they thin out the dead branches? I wondered if that's maybe more of a problem because the trees just die underneath as the light goes up.
That's more like a pruning thing that you might do on your own property, but also that it wounds the tree when you cut branches off of it, and it can actually invite bark beetles to come in to that wounded area, and it releases those volatile chemicals from the tree.
I just knew the dead branches underneath.
Yeah, they do that then. In a lot of the thinning, they're trying to get the fuel up off the ground so that it doesn't come from a ground fire and then move up into the crown of the trees and then be more severe. Yes, ma'am.
So if you leave your own home and you take your dead wood out and mistletoe, and you drink it in the cold weather. I've seen where you can solarize if you're getting in warmer weather, but I'm just avoiding that. Because that's it. Or get it out of there and ship it quickly. So anyway, is that responsible? Is that helpful? Does that take care of the fire problem and the health of the tree?
I guess I can't answer if it takes care of the fire problem without seeing what you're doing. So I'm supposed to repeat all the questions. The question was, I'm taking the dead branches off the trees and removing branches from trees, maybe the lower down branches, but in the winter time. So yes, that's ecologically good. That's a low time for bark beetles, and it gives the trees time to kind of dry out before the bark beetles can move in there and take advantage of that fresh wood. But yeah, as far as fire mitigation, there's a lot of good, as you guys probably know, there's a lot of good documents online with state forestry and different places about fire safety around, within a certain quarter mile of your home, what it should look like within 100 feet of your home. Yeah. Is it time?
What were the native grasses that you
Oh, great. So let's see if I can remember them all. Arizona fescue, bottlebrush squirreltail, rice grass. We found sand dropseed.
Blue grandma.
Blue grandma, Sido's grandma. How many was that? Couple more. Oh my goodness. Ha 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 ha. That's my methods. It's got to be down here. All right. Oh yeah, prairie June grass and needle and thread grass. Those are your two more.
And then what were you? Cheatgrass was one of the.
Cheatgrass and bromus inermis, smooth brome. Smooth brome.
Okay, thank you.
Yeah, you're welcome. Yes.
Yeah, thank you very much. Great presentation, but
Thank you.
I'm a little thick. And so I'd like to ask, so the treatment that you're talking about.
Yeah.
Can you just sort of explain again, what was the treatment?
Yeah. So prescriptions are a little bit fuzzy to read and understand exactly what happened on the ground. But basically they cut all the lower diameter trees out. So like in a 1/10 of an acre plot, which is maybe from further than me to you, but maybe this wall to the wall behind you is about that in a circle. There's now, instead of 80 trees or 60 to 80 trees, we're going to find 5.
So it was a really kind of radical treatment.
Radical.
It wasn't necessarily a thinning project or sort of discriminating about the health of the, or the canopy, or it was pretty radical.
Yeah, they wanted to, focus on taking out the trees with mistletoe, right? That was a priority. But mistletoe is funny, and a tree can be infected for 3 years before you see any signs of mistletoe shoots popping out. So now there's a lot of those trees do have mistletoe, actually. But mistletoe is not necessarily a bad thing either. A lot of insects need mistletoe when they're in their larval stage. So it's part of the forest.
I guess my question is, if the treatment wasn't so radical, if it was a bit more discriminating, or something that, I don't know, the sort of general, most thoughtful intervention might be, do you think the results would have been quite different? I mean, if it was a little bit restrained in the treatment?
Yeah, I do. So the question is, if the treatment had been more ecologically oriented, would we have different results than what we're getting here? And I would say definitely yes. And there's been studies out that show that treating areas for heterogeneity, which means making more complexity in the system versus what this is way less complexity, right? So when you have these treatments that focus on heterogeneity and biodiversity, you also achieve that goal of fire mitigation. So it definitely can happen and have different results in this and be more in line with the historic range of variability of this type.
That's good, because also we're all here at the Native Plant Society, but we're also worried about fire and doing these thinning projects properly, but being uneducated in this, highly scientific way, we get mixed messages. So I was just kind of wondering about that.
Yeah, it's so interesting because we're in the Pinyon too, been there for a while. We did a first wave of thinning because we were thick, and we always had a little barrier to our house, but man, and actually we have 5.5 years from the first thinning. It's the same crew that we're now having to do it a little bit more, but our land, the trees on our land responded very nicely. They seemed to grow more green and healthier. And so I think it is all about how it's thinned and not just,
Yeah, I agree with you. It is all about, and the sawyers on the ground actually being more educated about forestry and understanding what they're doing on the ground can make a big difference in implementing these prescriptions and make them turn out a little bit differently. Like my husband, as a sawyer, he gets to choose between the pinyon and juniper, and he always leaves some juniper. Oh, yes.
With the pine sawfly larva on the pinyon, how much damage does that do, or will it eventually kill the tree?
No, I don't think it's a primary insect pest. Do you have some on your land?
Oh, yeah.
Yeah.
So I've been in this war, because they're on the bristlecone, and they kind of moved my one pinyon, and, a couple of years ago, so I keep trying to make them go away.
Oh, I'd love to come check that out. Okay.
They'll be there in all their glory.
Interesting, yeah, and I'm interested in insects very much, so that would be great to see that. But yeah, as far as I know, they don't kill the tree. I have these insects coming and attacking my cherry trees, and they're like these green, juicy, weird things.
I believe those are kind of the same type of insect that I looked it up, but they have almost the same name, but they're like a different variety.
I talked to the extension at NMSU, and they don't kill the tree. They make it look ugly by eating it, but they don't kill it. So, yeah.
Have those.
Yeah. Any more questions?
You said that juniper was not a host tree for mistletoe?
For dwarf mistletoe.
For dwarf mistletoe, but am I correct that you can see dwarf mistletoe in juniper sometimes?
They have a true mistletoe.
Oh, they have a different mistletoe.
Yeah, it's a different, and true mistletoe are a little bit different because they make some of their own carbon. They don't take everything from the tree.
So does that mean that it's not as necessary to remove those trees?
It's not as damaging to the tree as dwarf mistletoe can be.
I thought, and maybe I'm wrong, maybe it doesn't really work that well, but I thought you could sort of manually just go in and kind of remove mistletoe if you see it kind of in one of your trees that you want to not have it destroy eventually, and just do it that way instead of cutting the tree down.
You can, and you can just remove the branch that's infected as well. Until the mistletoe gets into the bowl of the tree, then it can kind of travel around. But you can just, remove it as you see it. And it's slow growing. It takes 3 years from when it becomes infected to actually reproduce. So it's pretty slow growing. And once you remove the mistletoe, it's going to die. It doesn't keep seeding. You don't have to worry about it infecting other things after you remove it, or after you remove the branch. It's done. Yeah, okay, thanks everyone.
Thank you.